So once we've done some signal processing or signal conditioning, we actually get into the actual device or the data acquisition board. So if we look at our schematic here, it's this region over here that we're going to be interested in. And I'm trying to explain this section. So we'll go over multiplexers, which then feed our analog to digital converter, which then typically will go into our computer system itself, where it'll store the data, show the data, and then typically we can do some external. We can typically feed like the process that we're trying to control or measure. Sometimes, if we're trying to control maybe like the temperature or the force being applied or something like that, we can help control that process using the data acquisition system. Okay, but let's just go through the multiplexer, the analog to digital converter, and we'll talk a little bit about some of the stuff that goes on the control side. Okay, so So the multiplexer basically allows us to have a single analog to digital converter that can be used to measure multiple channels. So the idea there is you save money by not having to have an analog to digital converter for every single channel. And basically it also controls how often or how frequently we're measuring each of the individual channels on the system. Okay. An analog to digital converter, we talked a lot about this in the last previously, but typically most DACs will use either successive approximation converters that typically can go between 10 kilohertz and 10 megahertz. Parallel converters are used for very high frequency that can be up to 10 gigahertz, which is incredibly fast. And then low level voltage measurements typically use dual ramp AD converters, and those are very slow, typically around the order of 100 hertz to measure signals. Okay, so depending on how fast you need to do something and the level of the signal, you would choose between these different analog to digital converters. Right. On the opposite end, DACs, you typically have digital analog converters that typically can send analog signals. And typically the reason why you want to send an analog signal is we're usually trying to typically control some other electronics. So typically motors, for example, will have motor controllers, and motor controllers typically have a channel that they will read in, and that typically can be used to control the velocity of the motor by sending a signal that's proportional. So if you send a higher voltage signal, the motor spins faster. If you send a lower voltage signal, the motor either stops or it goes very slow. Okay. Third part that's often in a device is typically a digital input, all right, or outputs. Digital outputs are typically sent out to help control or signal to other devices to either turn on or off. And then digital inputs typically are used to be either statuses. So like a device might send a signal to the data acquisition board to say like I'm on or I'm working properly, and that would be send like a 5-volt signal and say I'm working. And if it turns off for any reason, that voltage goes down to 0, and then now we know that that device is no longer working or on. Okay, and then the last thing is that data acquisition systems either sometimes have these built in or sometimes they're an external device, but that typically a closed loop controller basically it reads in the process or reads in the signal from the process that you're trying to measure, and then it controls the output to improve the process basically so like if you're doing a temperature measurement, for example, and you're measuring, you have something set to be 100 degrees, and currently it's reading 80 degrees. The closed loop controller would turn on some type of heat source to increase the temperature. At the same time, if it went over the temperature that you wanted, it would turn off all the heat sources to make sure that you'd be within the proper range. Okay, so typically a common example of this is called a proportional integrated derivative controller or a PID controller loop. There's also like on-off controllers or like fuzzy logic controllers, but they basically all use the same ideas of that we're we're reading in data, and we're using that data to then adjust the process to match the value that we want it to be. Okay. All right.